This is Mrs. O'Neill for Chapter 11, Section 1, Part 2, Subscripts versus Coefficients. We need to understand which numbers are which and what those numbers really represent and do when we're balancing our chemical equations. So again, pause, fill in the blanks, make sure you're reading as you're writing, and then play to hear my words. So the subscripts are going to be the little numbers that you've already seen. Those tell you how many atoms of a particular element are in that formula. Remember, those are those numbers low to the ground. Okay, and they're always going to be part of the formula. They stay part of the formula, and we can never change that subscript, because if you change that subscript, you're changing the substance. So for instance, taking H2O versus H2O2 is hydrogen peroxide. So there's a difference between water and hydrogen peroxide with a simple change of a subscript. Now the coefficients are going to be the big numbers in front of the formula. Now remember, that formula means I can change a coefficient of an element or I can change a coefficient of a compound. It's going to be the big numbers in front, and we're going to need those to balance our chemical equation. So let's look at this visually. So if we see C, if we see the letter C and we see this one black dot, that represents one atom of carbon. Guess what? One capital letter gives us an element. If we see an O, capital O, one red dot, that's going to be one atom of oxygen. Again, that represents an element. If we see, however, O2, I see two red dots together. So yes, it is one of those diatomic molecules. It's one of those elements that will never exist alone. However, again, I only see one capital letter, so that's going to still be classified as an element. Just like all of those other Cliff H. Braun 7 diatomic elements or diatomic molecules, they're still going to be an element because they never exist alone. They have to be bonded with themselves to exist or with another element. Something like this, if carbon and oxygen are bonded together, now we have what's called a compound, because now I see two capital letters, one black dot, one red dot. So we have a molecule, or I should say a compound consisting of one carbon and one oxygen. How about if we change the subscript? So instead of having one, remember these are understood, right? C1O1, it's understood. But now let's change the subscript. Now we have C1O2. We've changed the subscript, and so now we not only have one carbon, but we now also have two oxygens. So I see two capital letters. I've changed the subscript from one oxygen to two, and the only reason why it's written this way is because of the structure of that compound. The carbon would be in the middle and the outside edges would be the oxygens, but I see two capital letters, so that's going to be a compound. Now, so not only do I see the compound of carbon dioxide, but now I see a 3 in front of it. That 3 represents a coefficient. Well, that technically means that I have 3 compounds of carbon monoxide, which tells me, let's look at how many of each element I have. 3 times the 1, now I have 3 carbon atoms. 3 times the 2 gives me 1, 2, 3, 4, 5, 6. I multiplied. 3 times the 2 gives me those 6 oxygen. So again, you might want to pause. You might want to write anything in the margins. You might want to do yourself a little favor and do a little visual as far as your circles. And if you don't have black and red colored pencils, you might want to just use a circle with a C in it and a circle with an O in it. But again, this is giving you that awesome visualization about elements versus compounds versus subscripts and versus coefficients. So it gives you that visualization of all of those things that are going to be those little pieces to make that big puzzle of balancing equations. So how do these coefficients work? we want to remember that they change the number of atoms of each of those elements in that substance. And again, it's going to be by multiplying. So every time we put a coefficient in front of a substance, and again, that substance can be an element or a compound, we're going to be multiplying it out, kind of like that FOIL method or that distribution method you use in math class. So let's look at example 1A. And I'm going to say this again. You might want to wait to hear the whole spiel and then pause to write down the information. So the first thing I'm going to strongly suggest is pull out the elements. And the reason I'm going to suggest that is because I'm going to ask you to do that every time we balance a reaction. Pull out the elements first. So first, we have hydrogen and we have oxygen. And notice again, I'm trying to color coordinate so it's easier to visualize. So how many hydrogens do we have here? Well, most of you are going to say 2 right away. And how many oxygens do we have? 1. That's pretty simple. We know water consists of 2 hydrogen and 1 oxygen. So pause the video and make sure you get this in your notes. So now let's put a 3 coefficient in front of the H2O. So now what's that going to do? Now again, I'm pulling out those elements first, and again, we have hydrogen and oxygen, but now the 3 really tells me that I have 3 water molecules. I have 3 water compounds. So now if I say 3 times the 2, I really have 6 hydrogen atoms all together. And that should make sense. Visually, I have 2 plus 2 plus 2. I have 3 times 2 of those hydrogen atoms to make 6 total. And again, what about those oxygens? Well, 3 times 1, right? That's an understood 1 here. 3 times 1 would be 3 total oxygens. So again, pause the video. You might want to do yourself a favor and do some of those arrows just so you're understanding. And maybe you want to put an X there to say that you are multiplying things out. So now let's look at 2. Again, listen to the whole spiel and then write down the information. So the first thing I'm going to ask you to do is pull out those elements. So I see 1, 2, 3 capital letters. So I'm going to have 3 elements to pull out. The AU, which is gold, C is carbon, O for oxygen. All right, so now how many AUs do I have? Well, I got 2 there. But now let's look at these parentheses. The carbon and oxygen are both in parentheses. Now remember when we did the molar mass or the formula mass, those parentheses mean that we have to multiply out. So it's really 3 times the 1 that's understood to give us 3 carbon atoms. And now it's going to be the 3 times the 3 for oxygen to give us the 9 total. Again, pause the video. You might want to do yourself a favor and draw those arrows, as well as maybe an X, or maybe making sure that you're understanding the multiplication of this. Now let's put a 2 in front of that coefficient, in front of that compound of gold carbonate. Okay, so what does this really mean? The 2 really tells us that we have 2 of these compounds. Okay, so if we have 2 of the compounds, ding, 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 we're basically multiplying out. So let's look at the gold. So 2 times 2 is going to give us the 4 gold atoms total. But now look at that carbon. So first it's going to be 3 times the 1 times the 2. Aha! So hopefully that makes sense. So if we look up here with the 2 compounds, 3 and 3 make 6 total. So not only are we doing 3 times the 1, we're also doing 3 times 1 times the 2. And it doesn't matter which order. You could have done 2 times 1 times the 3, or 3 times 1 times the 2. We're multiplying, so it doesn't matter the order of which you're doing it. So can you think for a minute of how many oxygens are going to be in this now compound with the 2 coefficient? So let's take a look. Hopefully you paused and thought it through. So 3 times 3, like we did last time without the coefficient, is going to give us the 9. But we also have to multiply by the 2 because we have 2 compounds. And that's going to give us the 18 oxygen atoms total. So again, hopefully that makes sense. Pause, draw your arrows, maybe even do a little color coordinating, and make sure you know that you're understanding the multiplication of all of this. So I will say that this is basically going to be your hardest type of element with a coefficient, right? A compound that has, I should say, a compound that has parentheses and a coefficient is going to be your hardest type of understanding or making sure we understand how many of each of those elements in that substance we have. So practice problems. Pause the video, see if you can do those practice problems. I'm going to say, at least for the first one, I'm showing you real quick here, pull out those elements first. Okay, make sure to pull out those elements first, because that's going to be really important. And if you notice here, 1 and 2 are the same. It's just the coefficient changes. 3 and 4 are the same, but the only thing that changes is the coefficient. So again, pause the video and see you can do 1 through 12, and I'm going to just kind of play it through and show you the answers. At this point, you should have paused the video and you should have at least tried. And if you have any questions or you're not getting something right, this is a good time to put a star or a question mark to ask me or another student in class at some point. So here's our answers, and I'm just going to kind of click through. Make sure to check your overall answers. And again, there's that tricky one with the parentheses, but then the 3 on the outside, and that's why you're multiplying twice. 5. Another one of those parentheses. All right, guys. Hopefully that makes sense, because that's, again, another little piece to the overall puzzle.